Hi everybody. Today we're going to be looking at some problems that deal with marginal and conditional distributions. So as we learned in class, remember, marginal distributions deal with either counts or percentages for one variable, whereas conditional distributions deal with one variable being some sort of a percentage of another variable. Okay, and we know that in two-way tables there are only two, right? They're both categorical. So let's take a look at the first problem here. It says James is interested in the relationship between weather conditions and train delays. For a year, James records the conditions each day as well as whether this train arrives on time or is delayed. Here are his results. Okay, so these are the results here. The weather conditions is one categorical variable and the other is the either on time or delayed, right? And we're also given the totals. And these totals here, this row total is highlighted. What is the best description of the distribution box in the last row of the table above? So if we look, okay, it looks like for these totals are for what? 330 is the total of all the trains that are on time, and 35 represents all of the trains that are delayed. And when you add those up, there's 365 trains total, correct? So if we look at our descriptions, if we look at our choices here, A, this is a marginal distribution of arrival status, okay? And that definitely looks like a candidate because again, they are the arrival statuses, right? For the trains, 330 arrive on time and 35 are delayed. This is the marginal distribution of the weather type. Well, the weather types are these. So these totals would relate to the weather types, correct? Not these. So that can't be it. And again, these are not conditional distributions because they only deal with one variable, whether it's on time or not, correct? The arrival status. Is it on time or is it not? These numbers don't tell us anything about the weather conditions, right? They're not broken up into the weather conditions. Okay, so these two, and then this conditional distribution of arrival status for snowy weather. So these do not look like the answers. And as I told you, a big hint as to whether it is a marginal distribution is if it is on the margins, correct? So totals are usually the numbers on the margins. So for this problem, looks like A is the best choice. And that is correct. Okay, let's take a look at another one. Here we have some data from a veterinarian. A veterinarian collected data about the kinds and sources of pets from his clients. Here is some of the data. So we have pet source, okay, where the pet came from, right? And the breed, the type. Is it dogs or is it cats? Okay, so here you have the data. The graph of which distribution is shown below. Okay, so it looks like each of these bar graphs relate to the pet source, right? So here we have from a store or breeder, stray, shelter, family, or friends, right? So each of these bars relates to the source, and for each source we have a percentage. And if we look at the legend, it looks like the light blue pertains to the dogs, and the dark, I guess the dark blue, this is dark blue or dark green, I'm not really sure, that relates to the cats. So it looks like each of these is broken down row-wise, correct? By row. So, so this sort of looks like, because it is by rows and it is by percentages, it definitely looks like a conditional distribution. Conditional distribution of the percentage of the either cats or dogs for each source. Okay? So let's take a look at our choices. It's not marginal because these deal with two variables, correct? The source and the frequencies. Okay? Relative frequencies for each source. Okay? So it doesn't look like it's marginal, definitely conditional. Conditional distributions of kind of pet for each source, that looks pretty good, right? And D is conditional distribution of pet source for each kind of pet. I don't think that's it. This is reverse, right? This is the opposite of what we have in this table. So it looks like C is the answer, and that is correct. All right, let's take a look at the next one. AJ has been recording his outcomes for 3 games that he has played this summer. Here is his data. So again, we have the totals. We have row totals highlighted. And these are games and then the outcomes, win or loss, right? What's the best description of the distribution box in the last row of the table? This is definitely a marginal again. And it looks like these numbers, 17 represents the number of wins, 20 represents the number of losses. So these numbers represents the outcome, right? So this is a marginal distribution of the outcome right here. Okay, that looks like the correct answer. So let me highlight that. And that is correct. And finally, again, a veterinarian collected data about the kinds and sources of pets from his clients. Here's some of the data. This looks like the same data, correct? But now it's presented in a slightly different way. So instead of here having 1, 2, 3, 4 bars, we only have 1 bar. The graph of which distribution is shown below. So it looks like here we have the relative frequency and then we have the totals. So this looks like of the overall total, it's 1, 2, 3, 4. So 1, 2, 3, 4. It looks like a breakdown of the pet sources, correct? This is the relative frequency of the sources, and sure enough, there they are, right? So each color represents the relative frequency of where the pets came from. Where's the source? Okay, these came from shelter, these from the family or friends, the store or breeder, and then strays. So definitely this looks like a breakdown of this column right here, correct? So this is actually a relative frequency for the margins. Okay, so this is a marginal. This is a marginal distribution of kind of pet. No, this is a marginal distribution of the pet source. That looks like it, right? And sure enough, that is correct. Okay, guys? Great.